What the James Webb telescope is able to do is to, in fact, what it was constructed to do, was to detect extremely long wavelength radiation, stuff that's out of term. So it's looking for very long wavelength radiation coming from galaxies that are very, very far out there. If the universe is expanding as we would expect based on the Big Bang Theory, then the radiation coming from things very, very far out in space and therefore very far back in time should be very stretched out, more stretched out than stuff that's closer at hand.
Imagine a world not bound by the warm glow of any sun, drifting alone through the vast interstellar darkness. Now imagine that world is not just a solitary wanderer, but the heart of its own miniature planetary system, a cosmic family, adrift together in the infinite night. This is not the stuff of science fiction, but the incredible new frontier scientists are exploring today. For centuries, our understanding of planetary systems has revolved around the familiar. Planets circle stars, just as the Earth orbits the Sun, and our solar system is a model of order in a chaotic universe. But recent discoveries are shattering this paradigm. Astronomers are now uncovering evidence that some planets are true cosmic nomads, giant gas-rich worlds that roam the galaxy without a star to call home. And even more astonishing, these free-floating giants may play host to their own planetary companions. These are the so-called rogue planets, vast Jupiter-sized spheres of gas and atmosphere set loose from their parent stars by the gravitational chaos of their early histories. Once thought to be rare, rogue planets are now turning up across the galaxy, their numbers perhaps rivaling those of stars themselves. But what if these lonely giants aren't entirely alone? What if they carry with them the seeds of new worlds, orbiting in miniature systems far from the warmth and light of any sun? A groundbreaking study led by an international team of researchers at the University of St. Andrews in Scotland has opened a new chapter in our understanding of planet formation. Using the extraordinary capabilities of the James Webb Space Telescope, astronomers have peered deeper into the darkness than ever before and found compelling evidence that these free-floating giants could, in fact, have their own planets, worlds orbiting worlds, drifting through the cosmic void. Let's look at what makes these discoveries so remarkable. In our own solar system, the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune, are accompanied by retinues of moons, each a miniature world in its own right. But these moons all orbit planets that, in turn, orbit the Sun. In the case of rogue planets, there is no central star. These planetary giants wander the galaxy alone, carrying with them only what they can hold onto with their own gravity. The question that has fascinated astronomers is simple yet profound. Could free-floating planets have their own planets? Or are these companions better described as moons? It's a debate that blurs the boundaries of our definitions. Alex Schultz, principal investigator on the project, points out that, traditionally, a moon is defined as a body that orbits something that itself orbits something else. In our case, the Earth orbits the Sun, and the Moon orbits the Earth. But when the parent world itself is adrift in interstellar space, that chain of hierarchy breaks down. Are the smaller bodies that orbit a free-floating planet moons, or are they planets in their own right? The discussion is ongoing, and the answers may redefine how we categorize the architecture of planetary systems. To investigate these questions, the research team focused on 8 giant free-floating planets, each with masses comparable to Jupiter. Observed by the James Webb Space Telescope from August to October 2024, these worlds were chosen for their size and their isolation from any nearby stars. Webb's powerful spectroscopic instruments allowed scientists to study the faint light emitted and absorbed by these distant giants, painting an unprecedentedly detailed picture of their environments. The results were nothing short of extraordinary. In 6 of the 8 cases, the Webb telescope detected signatures of warm dust swirling close to the planets. This dust revealed itself through excess emissions in the infrared, a wavelength of light invisible to human eyes but perfectly suited to Webb's sensitive detectors. Such dust is not just a random cloud. It forms a disk, reminiscent of the protoplanetary disks seen around young stars. These disks are the cosmic cradles where new planets are born. What does this mean? In the familiar setting of a newborn star, a protoplanetary disk of gas and dust surrounds the infant sun, coalescing over millions of years to form planets, moons, and asteroids. The discovery of similar disks around free-floating planets suggests that the fundamental process of planet formation is not limited to the domain of stars. Even a rogue planet, cast adrift from its birthplace, can gather and hold on to the material needed to build its own system of worlds. Worlds. Previous hints of such disks had surfaced in earlier studies, but Webb's observations have provided the clearest evidence yet. Not only do these disks exist, but they also appear to persist for several million years, long enough for the slow, intricate dance of planet formation to unfold. The building blocks of planets are not the exclusive property of stars. They are scattered across the galaxy, ready to assemble new worlds wherever gravity allows. As lead author Belinda Damian explains, these discoveries fundamentally change how we think about planetary systems. The process of planet formation is more robust and widespread than previously imagined. If disks of dust and gas can form around objects barely larger than Jupiter, then the potential for miniature planetary systems is vast. These systems would be like our solar system, but scaled down by a factor of 100 or more in mass and size. Instead of basking in the light of a host star, they would drift together through the interstellar dark, a family of worlds bound by gravity alone. The implications are immense. If planetary systems can emerge around rogue planets, the universe may be teeming with strange, starless families of worlds, invisible to ordinary telescopes, but waiting to be discovered by the next generation of astronomical instruments. These miniature systems may harbor exotic environments, moons with subsurface oceans, icy bodies warmed by tidal forces, or rocky worlds shrouded in perpetual night. The very definition of what constitutes a planetary system is evolving, and with it, our understanding of where and how worlds can form. With the discoveries made by the James Webb Space Telescope, the idea of miniature planetary systems adrift in the darkness between stars moves from speculation into the realm of real scientific possibility. Webb's infrared vision has unveiled warm, dusty disks clinging to half a dozen free-floating giant planets, evidence that these cosmic nomads might not be traveling alone. Instead, they could be accompanied by their own retinues of smaller worlds, forming starless families that challenge our deepest assumptions about how and where planetary systems can arise. The observations focused on 8 massive objects, each with a mass similar to Jupiter's, wandering through interstellar space. Remarkably, 6 of these giants displayed a clear signature: infrared emissions from warm dust close to the planets themselves. This dust, glowing faintly in the cold abyss, is the hallmark of a circumplanetary disk, strikingly similar to the protoplanetary disks around young stars where planets are born. But in this case, the central object is not a star, it's a planet. The building blocks of new worlds are swirling around these lonely giants, hinting at a process of planetary formation on a surprisingly small scale. Such disks could persist for millions of years, providing ample opportunity for dust and gas to coalesce into moons, or perhaps in this context, true planets in their own right. Scientists are still debating the terminology. Traditionally, a moon is a body orbiting a planet that in turn orbits a star. But these newfound systems flip that hierarchy. Here, there is no parent star, only a massive planet and its direct companions adrift together through the galaxy. Should we call these companions moons or planets? The answer remains an open question, as the language of astronomy evolves to keep pace with discovery. Lead researcher Belinda Damian and her team at the University of St. Andrews emphasized the profound implications of these findings. If planet formation can take place around free-floating objects only slightly larger than Jupiter, then the fundamental processes that shape planetary systems are even more universal than previously imagined. The cosmos may be peppered with scaled-down analogs to our solar system, systems with lower mass and smaller size, but with the same intricate architecture of central giants and orbiting companions. The process likely begins in much the same way as planet formation around stars. A giant planet, ejected from its birthplace or formed in isolation, retains a disk of leftover dust and gas. Over time, particles within this disk collide and stick together, gradually growing into larger bodies. Some may become icy satellites, others, rocky orbs warmed by tidal forces rather than sunlight. In the cold darkness between stars, these miniature systems would be invisible in visible light, but in the infrared, their heat betrays their existence. What might these rogue planetary systems look like up close? Picture a gas giant, swirling with storms even more colossal than Jupiter's Great Red Spot, encircled by a retinue of smaller worlds, some encrusted with ice, others blanketed by thick atmospheres. Without a star, the only energy would come from the planet's own residual heat and the gravitational tug-of-war between the central giant and its companions. In such an environment, a moon's internal ocean, warmed by tidal flexing, might persist for billions of years, raising tantalizing questions about the potential for life even in the loneliest corners of the galaxy. These discoveries also blur the lines between planets and brown dwarfs, between moons and planets. Astronomers are now searching for signatures of atmospheric chemistry, for evidence that these disks are actively forming new bodies, perhaps even catching one of these elusive mini-worlds in the act of birth. The next generation of telescopes, both on the ground and in space, will be able to probe these systems in even greater detail, searching for the faint gravitational wobbles or subtle eclipses that reveal the presence of orbiting companions. The implications ripple far beyond these 8 observed worlds. If free-floating planets can form and retain their own mini-systems, then the galaxy may be filled with hidden families of worlds, each evolving in isolation, each offering a new frontier for exploration. The Milky Way could host trillions of such objects, each a laboratory for the study of planetary formation, evolution, and perhaps even the ingredients of life itself. In the coming years, astronomers will survey the sky with ever more powerful instruments, peeling back the darkness to reveal these starless systems. The Roman Space Telescope, the extremely large telescope, and other cutting-edge observatories will help answer the outstanding questions. How common are these planetary systems? What are their true compositions? Do any of their moons or planets possess atmospheres or even liquid water? For now, the Webb telescope's revelations remind us that the universe is richer and stranger than we ever dared imagine. Not all planets orbit stars, and not all planetary systems need the warmth of a sun to form. Somewhere in the vast stretches between the stars, families of worlds drift together, unseen, but no longer entirely unknown. If you enjoyed this journey into the mysteries of rogue planetary systems and the possibilities they hold, make sure to like this video and subscribe for more content like this.